Yes. Introduce you guys to is the following here. Let's see. You guys are section. What section are you guys in again? I'm going to say this. Introduce you guys to hypothesis testing about two what means. Okay, and I think you're section 16408. Okay. I'm going to enter this in the iPad. All right, you guys okay with that? So where are we at? Okay, what is this? Okay, this is online. I guess I did not show you guys that, and I entered this in the iPad here. Okay, so you know what you can do is the same thing about means, meaning you have two independent means, two different groups, and your mean is a different measure. It's a different parameter, right? Mu is different than P. So now you have really two means to compare from two different populations again. Two independent populations, two means. And what's the biggest thing to work on at first again is language. So when they say that the two means are what? Are the same. What does it mean for your means to be the same? Mu1 is equal to what? Mu2. They are what? The same. Now, what does it mean for your means now? Okay, they're going to say your two means now are what? Not the same. So what do you guys know about that? It's not equal. Okay, and again, let's focus on this one again. What does it mean when they say that the means are what? Are different. What does it mean to be different? Not equal.
Is this the same one as the other?
Very similar, but they changed the parameter now. What are we working with? Means. Good. It's a different parameter. Now, when they say the means are what? Are not different. What does it mean not to be different? Yeah, it means you are the same. If you say to somebody, I'm not different, you're saying you're the same. All right? It's the language again. And you guys know this is probably for some people the hardest language. What's easier for some is the more than and the less than, right? So you say mu1 is what? More than. More than what? Mu2. Mu1 versus mu2, more than is what? Greater than. Less than. Mu1 versus mu2. You have what again? Less than. Smaller than. And then, of course, mu1 is what? No more than mu2. That is less than or equal. We've been aware of that. And again, I have my typo here, so I have to remember one day to fix that. And I will. mu1 is at least. If I can get a highlighter here.
Wait, what was after not the same?
Oh, in these notes?
Yeah.
Different. Oh, this phrase more than phrase. So you guys have And again, you have this on the website. Anybody here download the notes by any chance? We got one person who downloads it. Anybody else?
Honestly, I
2 people. Do you find it helpful? Okay, good. That's the whole idea. All right. You guys okay with that? That's the whole idea. All right. So you might say to me, okay, what's the process? It's the same process. The only thing you guys have to learn here, and yes, now I do have to say this. This is a little interesting. The process here, there is one big assumption that's different than the others here. This is when the population standard deviation, sigma 1 and sigma 2, are unknown. And when they're unknown, we've used what's called the t-table, okay? Just so you guys know, when they're unknown. And that's the student distribution. However, we're going to be using the modern method. You say, what's the modern method going to be? We're not going to use that. What we're going to use by the modern method is this. This is going to be what? Stat test 2 sample what? T-test. Okay, now this is, yes, on your test, you get to use your, I'll give you the summary sheet. Okay, and that's going to be the TI command you guys use. It's a 2 sample t-test now. But we're now comparing means now, ladies and gentlemen. So this is where, if we compare 2 means, this is where I can talk about who's smarter, men or women, in terms of IQ scores. All right, so shall we try this? You say, Mr. Judge, I don't want to go there. Okay, sorry about that. Is that wrong to talk about that? Let's be scientists today. Here's what we're going to say. The mean IQ for men is different than the what? Mean IQ for who? Women as what? Claimed by who? Snodgrass. Now, the first sample, we're going to give it to you this way. And that's going to be for men. Well, IQ for men is different than the mean IQ for women. Okay. So this is the men. They're going to give you a sample size like 50. They're going to give you a sample mean now, like maybe 121.2. Or let me change that one. 118.2 with the standard deviation. This is from the first group. Let's say it's going to be 12.6. And then the second sample will be what? Sample size will be 75. That's the sample mean here, maybe 122.2. The sample standard deviation is going to be 8.6. And they'll say use the 5% level of what? Significance to test this claim. So we're going to try this. What do you guys think? Okay, now, this is a different parameter. Or these are different parameters. What are the parameters now? The mean for who? Min, what's the phrase? Is different than the mean IQ for who? For women, as claimed by Snodgrass. So, you say what? Mu1, mu2. What's this phrase? Different? Not equal. So, mu1 is not the same as mu2. This is Snodgrass's claim. Notice what Snodgrass is saying. Snodgrass is saying is that they just don't have the same. That's not the same IQ. They have a different IQ. That's all Snodgrass is saying. All right, you guys okay with that? Easy peasy. Now, where do you place this? Is that a null or an alternate hypothesis? How do you know? The not equal, the lack of equality. It goes down there. Good. And then the logical opposite, mu1 equals what? Mu2. So, ladies and gentlemen, this is a what kind of test? The two-tailed test. Okay, you guys okay with that? Now, we're going to use the modern method. You guys like the modern method? Anybody here like the modern method? 5% level of significance. What does the modern method do? You guys remember? It's your alpha. %5 level of significance. Okay. What's the deal with this? The group of men. So this is the men and this is the who? Women. What do we use? What do we use here? Do you guys know? Well, what do we say we use? Let's scroll all the way down. These are the notes. You know what we use? Two sample what? T-test. Two sample T-test, ladies and gentlemen. So in your TI, two sample T what? Test. Okay. This is the command in the TI. So, ladies and gentlemen, go to the TI now, like you've been doing, and what do? You go to what? Stat test. Where is the two sample T-test? It's number what here? Did you guys see it? It's number what? 4. Good. Okay, now, notice you're going to have what? Mean 1, standard deviation 1, sample size 1, mean 2, standard deviation 2, sample size 2, and then you pick your test. Now let's go through this, ladies and gentlemen. Let's go take a look again. This is your sample information, okay? So in the TI, we got to enter this. Let's do this here. All right. Sample mean 1. Maybe it's nicer to see everything out here. Okay. Sample means what? 118.2. What's the sample standard deviation? 12.6. What's the sample size? 50. What's the sample mean? For the second group, 122.2. This is for the women. How consistent is that? That's 8.6. What's the sample size? 75. And then, what kind of test is this? This is a two-tail test. Hit equal for two tails. Okay? You should see all of that same information right here, ladies and gentlemen. Same information, okay? Now, scroll down. Pooled is going to be no. And hit calculate. What's your p-value, ladies and gentlemen? Oh, look at this one. Your p-value is approximately what? What is that? To the nearest thousandths. What's this? 0.05 what? 3. You guys see that? 0.053? All right. That's your p-value. Is that p-value less than alpha? Is it? So what we're saying is that 5% or 5.3% smaller than 5%. This is 5.3%. Is that less than what? 5%. What'd you guys say? Is that true? Say what? Hope you guys know the difference. Say no. Is that a no? I mean an N-O no, not N-U-L-L no. 5.3% is not smaller than 5%. What does that mean? We have to keep the what? You keep the null. So in this case, the null doesn't go. And you say, okay, keep the what? Keep the null. If you keep the null, you got to get rid of the what? The alternate. What did we just get rid of? By getting rid of the alternate, we got rid of the excuse me, we got rid of the claim. What is that saying? The sample what? Does not support the what? Claim. Why does that sample not support the claim, ladies and gentlemen? Do you guys know why it doesn't support the claim? Because we crossed it out. So this test, you want to know what this test is revealing or saying? That the mean IQs are the same. So Snodgrass is wrong. Men and women have the same IQ based on this what? Hypothesis test, really based on the sample information. What do you guys think? Isn't that interesting? You want to know what's really more interesting? What if they did this? I'm going to write this down. Let's note this. What if they said use the 10% level of significance? What if that was your alpha? That p-value is less than what? Alpha. What's your p-value, ladies and gentlemen? So if they gave us the 10% level of significance, okay, what would you guys say now? Anybody want to tell me? Is the 5.3% smaller than 10%? Okay, good. You want to know what that means? What does that mean? It means your p-value is what? Low. And that means the null has to what? Go. When your p-value is what? Low. The null has to go. So in that case, let me go back here. Let's copy this. This is a note. This is a what if. I just want to share with you guys that 5.3 was close to 5%. So if that level of significance was actually 10%, then what happens? The null has to go. And when the null goes, you accept the what? Alternate. And what's the alternate mean? What does that mean, ladies and gentlemen? Now, the sample what? Supports the what? The claim. Easy peasy what? Lemon squeezy. Okay, so I just want to share that with you guys. I don't know. I mean, I put a whole bunch of notes there for you guys. So I'm going to check here. Homework what? 4. Edit. So what I'm going to add here is this. Hypothesis what? Testing about 2 proportions. And I'm not going to do the other 2 means because we just did one example. Okay? All right? You guys good with that? All right, ladies and gentlemen, take care, stay safe. I hope you guys have a wonderful, take a look at the homework I just did. When is that homework due? Tuesday. All right, take care, stay safe. Hypothesis testing about 2 means. So this is the work we were working on last time. Hypothesis testing about 2 means. And I did put, last time in the chat, I did put the link. So there you go, ladies and gentlemen. Wow. Wow. Okay. And I do have those same notes, good afternoon, in my iPad. So we're going to give you guys some more, maybe give you a little warm-up. There we go. Well, that's the notes we went through. How about if we say this? Let's give you another example because you're going to use, again, 2 sample t-test here. So let's see. Let's find it. I thought there were some notes on that. All right. Maybe not. We'll create them. Okay, so we'll call this hypothesis testing fall. Okay. Good afternoon. So let's give you hypothesis testing about 2 means. So ladies and gentlemen, let's do an example here. We're going to say the mean sleep time for men, okay, I'm going to say is the same as the mean sleep time for women. Okay, again, as claimed by Snodgrass. Okay, now I'm going to give you some sample information. So here's the sample information for the men. I won't write it down. I'll say the sample mean for men is about 7.2 hours. Sample standard deviation, we'll say, is 1.8 hours. And the sample size was 120. Okay? The sample for the women had a sample mean of, that's the second sample, of let's say 7.5 hours with a standard deviation of 1.2. Now the sample size for the women, we'll say, is 150. Use the 5% level of significance to test this claim. So I'll give you guys some time to write this stuff down. We'll go through it together, but it's another 2 hypothesis testing kind of question, okay? There you go. Okay, okay, did you guys write this down? So we're going over some more examples of hypothesis testing of 2 what? What are the parameters again? If it says mean, what are they? That's a mean, is that true? So we got mu1, mu2. What's the claim?
It's the same.
Have the same sleep. So that's going to be what? Equal. Here's your claim. So when we write this stuff down, what do we know? We put what? Here's what's going on. We have what? Mu1 equals mu2, and then that's the what? That's the claim. So here's our what? Null hypothesis. Here's the alternate hypothesis. And that's going to go where? Do you guys know? That's a null hypothesis. And then mu1 is not mu2. So is everything okay so far, ladies and gentlemen? So far so good? You guys remember that. Now, remember this here. We're going to use the modern method. So 5% level of significance by the modern method, right? Alpha is 5%. We need to check if the p-value is low. And you say, what do you mean low? The p-value needs to be smaller than your what? Level of what? Significance. So last time, and I downloaded the notes. Let's see if you guys can see. Where are we? It's going to be, we're not using the traditional method. We're using the modern method. So that's good. If you want to look at the traditional method, you can. But what are we looking for here? Stat test. This is going to be 2 sample what? Not z-test, but what? T-test. Now you say why, okay? So let's go back to our notes. You're going to use 2 sample t-test. Oh. Now I know typically you say, but isn't that a large sample? And you go, oh my God, why is it the t-test? Well, because the detail here is you use this when you do not know the true standard deviation values, right? When these 2 values are unknown. And they're unknown, and that's a small technical detail. Now, will you guys have that on your summary sheet? Yes, because I let you guys use a summary sheet, okay? So it's going to be there. I'll provide you the summary sheet for your final. It's the same summary sheet you guys have been using. It has this information. If you want to see it, you go, I want to see that summary sheet, Mr. Judge, because I just don't understand what you're talking about. Well, I did give you guys a summary sheet that you've been using. Bless you, is right here. So let's download it. It's a big file, so it's going to take some time. So time. Okay, you guys see this? 2 independent means. What does it say? Stat test 2 sample what? T-test. Okay, you guys okay with that? So you go, oh, wow, that's pretty good. So let's go to the TI now, okay? All right, so in our TI, if we scroll kind of in a bit, we want to do 2 sample t-tests. So we can say what? Stat test 2 sample t-test. What's the first sample mean? 7.2. What's the first standard deviation?
1.8.
Sample size. Second sample mean.
7.5.
I guess I hit something wrong. Sorry. Stat test. Let's go back. 2 sample t-test, number 4. Okay, now we're in the second standard deviation. So that's 1.2. And then the second sample size will be what? 150. Is this a 2-tailed test? How do we know it's a 2-tailed test? Oops, sorry. Yeah, let's go back here. Right? It's a 2-tailed test because of what it always tells you. The inequality here is not equal 2 tails. Okay. Calculate. What do you guys get? What does this say? What's the p-value? Right? Let's go to the nearest thousandths for the p-value. So the p-value is going to be approximately 0.118. And when it's 0.118, is this actually smaller than 5%? Say no. What does that mean? You keep the what? You keep the null. It's when the null is low, lower than the level of significance, then it has to go. But if that's not happening, you keep the null. And so when we keep the null here, say, what does that mean? We're keeping the null. Well, when you keep the null, you're getting rid of the alternate. So what does that mean in this case? Sample supports the claim. It means the means are the same. So it does mean that men and women get the same sleep. Okay, men and women get the same sleep. Your conclusion, the sample supports the claim. There it is. Easy peasy lemon squeezy. You guys like that? Let's give you guys another one. Let's compare men and women here, okay? So men and women get the same sleep. How about this? Huh? So, well, let's see. Who has more friends on social media? Men or women? What do you think? Men and women, who has more friends?
I wouldn't know.
How about if we just conduct a test? We'll say this, right? The mean number of friends men have on social media is less than the mean number of friends for women. As claimed by Snodgrass, okay? Use the 1% level of significance to test this claim when the sample information is below . Okay, so we're going to take again two groups again. The men, let's see, they have a mean number of friends on social media to be maybe, I don't know, 122. Standard deviation will be 21.6, 200 sample size. For women, we're going to say the sample mean for women is 138 with a 36.1 standard deviation, and that sample size is 180. Okay? So take a look at the information, write that stuff down. Okay, you guys okay with that? Let's read this now. What does it say? The mean number of friends that men have, that's the first group. Men is what? Less than the what? Mean number of friends for who? For women. And then that's the claim by who? Good old Snodgrass. All right. Mu1 is less than mu2, and here's your what? Here's your claim. So where does this come from, or where does this go? Is that a null or an alternate? A null or an alternate? Null or an alternate? Where do you guys put that? Good. Why is it an alternate? Because there's no... Yeah, there's no what? Condition of equality. So what's the logical opposite of that statement? Mu1 greater than mu2. What kind of test is this, by the way? Good job. It's left tail. Is that right? We're going to use the modern method. The level of significance is 1%. Right in here. Use the 1% what? Level of significance to test this claim. So we have to check, is P smaller than alpha? Is P less than alpha? And alpha being 1%. So here's the sample information for the first group, sample information for the second group, and then remember, this is what we're using here, okay? But remember, what test do we use? Two sample t-tests. I would even write that down, okay? Because that's kind of important. Stat test. Two sample t-test, number 4. So what's the first mean? 122. What's the first standard deviation? Is that 21.6? What's the first sample size? 200. Okay, now go to the second group. The mean number of friends is 138. 36.1 standard deviation. What's the next sample size? Is that 180? What kind of test is this again? Anybody remember? Left tail. That alternate hypothesis is inequality is pointing to the left. Left tail. Hit calculate, and ladies and gentlemen, what's your p-value? Isn't this approximately 0? Okay, is that less than, remember, this is scientific notation. That's e to the minus 7, so your p-value is approximately 0. Is the p-value low? Is that p-value of 0 less than 1%? Yeah, so the p-value is low. What does that mean about the null? You gotta sing it out loud. The null has to what? Go. When the p-value is low, the null has to go. So you go, oh my God, the null goes. Goodbye, null. And when the null goes, you accept the what? Alternate, and that happens to be what? the claim, ladies and gentlemen. So, the mean number of friends that men have, because they're in the first group, is less than the mean number of friends for the second group, which is women. We say the sample what? We should say the samples. The samples support the claim. What do you guys think? Easy peasy lemon squeezy? Yeah. Okay. You guys ready for another one?
Sure.
Should you guys try these? The mean what? Oh, let's see. What about... you guys want to compare men and women again? What should we compare? The mean hours, the mean study hours for men is greater than the mean study hours for who? For women, as claimed by who? Snodgrass. Okay. So here's the sample information for the men. Say, guess what? The men study, and this is like maybe in a day, for, 2.4 hours. The standard deviation of 0.6 hours, and then the sample size for that first group is 50. And then for the women, you got a sample mean here of maybe 2.8 hours. Sample standard deviation of 1.1 hours, and the sample size is 75. Okay, so we're kind of back to the old format. Use the 5% level of significance to what? Test this what? Claim, okay? So I'm going to have you guys try this out yourself, okay? I want to have you guys try it. We're going to give you guys some time. And let's see how it goes, okay? Let's try this out. Okay. So, ladies and gentlemen, let's try this out, okay? What does it say? The mean study hours for men is what? Greater than the what? The mean study hours for what group? Women, as what? Claimed by Snodgrass. So, greater than. So we're going to say what? Mu1 is greater than mu2. And what is this? The claim. Okay, so we're going to set up the hypothesis. And then you guys have to tell me, where do we put this? Is that a null or an alternate? A null or an alternate? A null or an alternate? What do you guys do? Where does that go? It's an alternate. Why? Why is it an alternate? There's no equal. Good job. Good job. You guys okay with that? Okay, so what's the logical opposite now? Mu1 is less than or equal to what? Mu2. Okay. They want us to use what? The 5% level of significance. So alpha is 5%. Is that true? So we're going to use the modern method. And let's see what this is. P is less than alpha. Okay, you guys okay with that? Two sample what? T-test. We're going to enter this information. We're going to get the p-value. We're going to see if it's less than the level of significance. Two sample what? T-test. Stat test. Two sample what? T-test number 4. So, ladies and gentlemen, what's the sample mean? 2.5. Sample standard deviation is 0.6. Sample size is 50. Sample mean will be 2.8. Sample standard deviation is 1.1. What's your sample size? 75. What kind of test is this, ladies and gentlemen? Do you know what kind of test this is? You guys want to tell me? The alternate hypothesis. What does that say? Where is that pointing? This is a right what? Tail test. Because it's pointing to the what? To the right. The alternate hypothesis, okay? So make sure that's pointing to the right, and it is. If I scroll down to calculate, what do we get, ladies and gentlemen? What's that p-value again? What's p? P is approximately what? 0.974. And I'm going to say something about this value, okay? That value is very much not less than the level of significance. It's not less than what? This alpha. So the p-value is high. It's not low. And the p-value, remember, is a probability that the null hypothesis is valid. That's bigger than 95%. It's almost certain to be valid. So we have to keep the null because it does not satisfy the inequality. So we keep the null. If you keep the null, what does that mean? Keeping the null means the alternate is what? Out. So we hug the null, and you're getting rid of the alternate. What did you happen to get rid of? You just got rid of the what? The claim. So what does that mean? The sample does not support the claim. We got rid of it. So this sample suggests that, ladies and gentlemen, here's your conclusion. Sample does not support the claim. That the mean is less than or equal to mu2. So, yeah, the mean study hours for men is greater than the mean study hours for women. No, that's not the case. There it is. What do you guys think? Isn't that interesting?
That was pretty interesting.
Should we try one more just for fun?
Yeah.
Let's say this to you guys, okay? Who eats more, men or women? I have no idea. Should we say this?
I don't know about that one. I don't know.
The mean calories for who? For men is not the same as the what? Mean calories for who? For women, as claimed by who? Snodgrass. So let's give the men group information, okay? The sample mean for men calories, and this is going to be like calories per day, okay? So let's say men have like about maybe 3,200 calories. Sample standard deviation is 268.4. The sample size we'll say is 250. Now for women, we're going to compare. We're going to say, okay, ladies, sample mean of calories is 3,000, let's say 3,080. Sample standard deviation is 236.8. And the sample size here will be 300, okay? They're going to want you to use the 1% level of significance to test this claim. And of course, we're using the modern method, right? So I'm going to give you guys some time to copy that before we proceed. Okay, let's go through this. You guys okay with that? What does it say? The mean calories for men is not the same as the mean calories for who? Women. And then that's the what? Claim. And how do you write is not the same? Is not equal.
Basically, an alternate.
Where does this go?
Alternate.
Is that a null or an alternate? Null or an alternate?
Alternate.
Good job, because they're not equal. Is that right?
Yeah.
And so remember, that's the claim. We always want to put that word down. Don't forget that. I almost did. The opposite statement is that the means are equal. Okay? What's alpha again? 1%. There's your alpha. So we're going to use the modern method, the what? The p-value method, ladies and gentlemen. We're going to check, is p smaller than 1%? Is the p-value less than that 1%? Okay. Two sample what? You know, you can write it down. Let's try this out. Stat test. Two sample t-test. What's the sample mean for men? 3,200 calories. What's the sample standard deviation? 268.4. And that sample size is 250. That's a pretty big sample, by the way. And then what's the sample mean here? 3,080. Standard deviation is 236.8. 300 sample size. What kind of test is this? Isn't that a two-tailed test? Two-tail? Okay, let's hit calculate. What's the p-value? Your p-value is approximately what? 0. And because that's scientific notation, that's 8 to the that's times 8 to the times 10 to the minus 8. You move the decimal 8 spaces to the left. So what that says is this p-value is less than what? That p-value is smaller than the level of significance. 0.000 is less than 1%. What does that mean? If the p-value is low, then null has to go. Goodbye, null. What does that mean? That the means are different. The sample supports the claim. Okay, the sample supports the claim. Mu1 is not equal to mu2. Okay? So that means men and women do not eat the same amount of calories per day. That's what they're saying. We eat different calories. What do you guys think? Okay, pretty good. Now, what I want to do today, ladies and gentlemen, I'm going to introduce you to another very